we have a couple words that you need to understand. One of them is a rate. One of them is a unit rate. And the other one is a proportion. Okay, they're all similar to each other, but they have a little bit different meaning. Rates can look like fractions. For example, if I did 2 to 3, it looks like a fraction, right? But when we talk about rates, you read them differently. You read them as 2 to 3. For example, if you are at a pet store and you're talking about the number of cats to the number of dogs, I would say there are 2 cats to 3 dogs. That means for every 3 dogs, there are 2 cats. Okay, we don't say there's 2/3 of a cat. That'd be weird, right? So we say 2 to 3. There are 2 cats to 3 dogs. And it's important that you put your label on this because you can't get it confused with your labels. For example, if you said 2 cats to 3 dogs, is that the same thing as 2 dogs to 3 cats? Or is that something completely different? Right. So you need to put labels on these. You need to write what that rate is or the ratio. And actually, I got this mixed up. This word should be ratio, not rate. Rate is something else. I'll talk about that in just a minute. So a ratio is how 2 things are compared to each other. We could talk about this in a couple ways. We could talk about a part of something compared to another part of something. We could talk about the whole being compared to a part. We could talk about a part being compared to a whole. All of these are different. Look at my 2 cats to 3 dogs. Is that a part-to-part comparison, a part to whole, or a whole to part? What do you think?
Part to whole.
It would be a part to part. Because do you think that there's other animals at this pet store? Yeah. Do I have a total in that ratio? 2 cats to 3 dogs. Do I have a total number of animals? No. Let's say that I did this. There are 2 cats to 25 animals at the pet store. What is this? This is part to whole. If I flipped it and said, for every 25 animals at the pet store, there are 2 cats. This time it's a hold apart comparison. Do you see the difference? Okay. Understand this. Understand that a ratio is a way to compare 2 different things. It's not to be thought of necessarily as a fraction. Is it related to fractions? Yes. But we need to use ratios when we're comparing 2 different things. Okay, so from that, I'm going to go into unit rate and what a rate is. A rate is the ratio that's comparing 2 different quantities. The word quantities is just a fancy word for the number of something. Okay, so a rate is the measure or the ratio comparing 2 different things. So rate and ratio are very, very similar. Rate is the comparison. Ratio is the way that it is written. Okay, for example, if I said that the Lawson family's rate is 288 miles in 6 hours, what 2 things am I comparing? Am I doing a part to part, a whole to part, or a part to a whole? What do you think? What did you say? Not a whole to part. I'm doing part to part, right? Right? Because I'm talking about what part? Miles. What part? Time in hours, right? So they're 2 different things. So I'm doing a part to part comparison. Now, what it's saying is in 6 hours, this family goes how far? 280 miles. Okay? Now, when we talk about rate, for example, when we're talking about the distance traveled in an amount of time, there's a word for this. Miles per hour. What do we call that?
OPH.
Your speed, right? It's how fast you're going. So the distance traveled over your time is your rate of what? Your speed, right? You need to know that this can be interpreted as speed. So whenever I'm talking about how fast something is going, I'm talking about two things. How far they go and how long it takes them to go that far. Okay? Now, go back to the family that went 288 miles in 6 hours. When we talk about speed, do we say that? I went 288 miles per 6 hours. How do we usually say it? Pick a number. Let's just say 50.
I went 50 miles an hour.
In 1 hour. So there's a new name for this. We call it a unit rate. When we're talking about something out of one, it's a unit rate. This is how we talk about speed usually, is we give a unit rate. How fast was that family going in an hour? 1 hour.
48 miles per hour.
Okay, so what we're going to do is we're going to create a proportion. A proportion is two ratios that are equivalent to each other. Equivalent is a fancy word for equal. A proportion is two ratios that are equal to each other. They're just written differently. I want to convert this or create a proportion for how far I go in 1 hour. Now, last week we learned about how to do cross simplification. This is different than cross multiplication. When you cross multiply, it's a way in which you can figure out a missing piece on a proportion. Let me show you how it works. If something is proportional, the cross products, these two, I'm solving for this, and these two will equal each other. The cross products, which is what operation? What is product? The answer to a multiplication problem. Remember, factor times a factor is a product. Wyatt, put it away. Okay, so the cross products will equal each other in a proportion if they are proportional. So what we can say is 288 times 1 should equal 6 times x. We don't know what x is yet, right? Can we solve for it? Yeah.
5, 6, and 2.
Okay, yep. So first we're going to solve this. What is 288 times 1?
288.
Put your terms together that can go together. And then I'm left with this. Can I solve for x?
No.
Sure, you know how to do this. Times by 6, do the inverse. Divide by 6, divide by 6. This cancels out. X is going to be 288 divided by 6, which should be what? Someone with a calculator. What is it?
48.
Yep. Good job.
Oh, right.
Okay, what would our label be? It goes x equals 48. What unit is it lined up with? Miles. Therefore, see how your miles line up with miles and your hours line up with hours? So our answer should have the label of miles. So, right, the whole unit rate would be said as 48 miles per hour. This is what we call a unit rate. This is how fast they go in 1 hour. You can also do this with money. People do this when you go grocery shopping. Let's say that you're talking about potatoes. I don't know what the going rate is for potatoes, so I'm going to make up a number. It's probably unrealistic. Okay, let's say that it's $8 for 3 pounds. And I want to buy, okay, so I'm buying potatoes. There's two different kinds of potatoes.
Potatoes?
Well, let's say they're the same kind of potatoes. I'm just going to buy the good old-fashioned normal potatoes. But there's two different brands, and I want to buy the one that's cheaper so I can save more money. Okay, the first brand is $8 for 3 pounds. The second brand is $16 for 3.5 pounds. Can I compare them the way they are? I cannot, because they are not unit rates. When you're comparing, you want to figure out how much does just 1 pound cost of the first brand, And how much does 1 pound cost of the second brand? Then you can compare the $2 amounts. So we need to convert to a unit rate. Okay, so remind me how much these potatoes cost. $8.
Yeah, $8 for 3 pounds and $16 for 3.5.
Okay. I want to do a unit rate. How much will it cost for just 1 pound for the first brand? So remember, cross products will equal each other. Okay, so you remember that the cross products should equal each other if it's a proportion. Do we want it to be the same value on each one? Yes, because I want to figure out how much 1 pound costs. So I know that 8 times 1 should equal 3 times something. We don't know yet, right? So I'm going to go solve these, because can I put them together? 8 equals 3x. Divide by 3, divide by 3. This cancels out. I'm left with x equals. Solve it. 8 divided by 3. Round to the nearest hundredth because money goes to the hundredths. Right? Good. So what this is saying is for 1 pound, it will cost $2.67. Brand A. Let's figure out how much the unit rate is for brand B. It costs $16 for 3.5 pounds. Okay, so we're going to set up a proportion. We want to do a unit rate. So when we talk about unit rate, that bottom number must always be 1. How much for 1 pound? Okay, so I know that the cross product rule, 16 times 1 should equal 3.5 times x. We don't know what x is, but we can solve for it. Can I put those together? Good. 16 equals 3.5x. Solve for x. This cancels out. I'm left with x equals to 16 divided by 3.5. And you should get $4 round to the nearest cent. $4.57 for 1 pound. Which one is the better buy? Brand A by a lot, right? It's almost, well, it's pretty close to half the cost, right? Okay, so this is how you do this. In order to figure out what the better buy is, you always have to figure out the unit rate because you have to compare 1 pound with 1 pound. And then you compare what the dollar amount is. When we talk about our rates or our ratios, the top number gets the name of the first term. The bottom number gets the name as the second term. Okay? So whenever I say unit rate, your second term must always be 1. And you must put labels on these. Because when you're setting up a proportion, your units across the top must match. In this case, your units across the top are dollars, and your units across the bottom must be pounds, and they must line up. Because if you wrote it like this, $8 to 3 pounds, and then you're solving for 1 pound up here over x, are you going to get an accurate and correct answer?
No.
No, because you don't have your units lined up the proper way. All right, let's do some problems together. Look in your text. During exercise, Sonia's heart beat 675 times in 5 minutes. How many times does it beat per minute? What are you asked to find? Per minute. Set your rate up, your ratio, so that you know what your first term is, you know what your second term is. The first term, they want what? Beats. Per second term? Minute. Beats over minutes. What information am I going to use? Good. And I know it needs to go on top because they want the first term as beats. 675 beats per 5 minutes. This is the information I'm going to use. I'm going to create a proportion. I want to know how many times it will beat in 1 minute. I know that my second term needs to be minutes. It needs to go on the bottom. So now I'm going to use the cross product rule. Now, there's a fast way to do this. Every single time that you write this down, you're going to multiply these two because they're the ones that are across from each other that you have two numbers. Because do I have two numbers this way? Not yet, because I'm solving for x. But I know it's going to be 5 times x that it's going to equal. Every single time you multiply the ones that are across from each other that you have numbers, and you get an answer, a product, and every time you're going to divide it by the second term that is not across from an actual number. Every time. So when you do cross multiplication, you can go multiply, divide, and you'll get your answer. So you're going to go 675 times 1, 675 divided by 5. And you get 135. Therefore, you would answer that Sonia's heart is beating at 135 beats per minute. Okay, why does this matter? If you become a nurse or a doctor, you will be doing this. This is a vital sign. This is something that tells you how someone's body is doing. Okay, people's heart rates at normal resting, like adults, should be somewhere around 68. Look at this number. Okay, so what's she probably doing?
Exercising.
She's probably exercising. And if you look at the word problem, it tells us she is exercising. But if she was just sitting there doing nothing, is something probably wrong with her? Yeah, this is how doctors and nurses can tell if something's wrong with your body. Okay, it's important to know how to do this because you use this in your everyday lives. Okay? Next one. To make 4 large pizza pockets, Paul needs 14 cups of broccoli. How much broccoli does he need for 1 large pizza pocket? What do you ask to find? Broccoli per pizza. This is a part to whole comparison, right? Okay. What information are we going to use?
He needs 14 cups to make 4 large.
What's my first term?
14. Broccoli.
It should be broccoli. So make sure you use that information. Put a label on it. Cups.
To make 4 large pizzas.
To make 4 pizzas. We're going to create a unit rate, so I know that my second term needs to be 1 pizza. We're going to figure out how much broccoli he needs. So we're going to go 1 times 14, and then do what with 4? So we're going to go 14 divided by equals 3.5 cups of, whoa, I don't know what's going on here. Spell this right. Okay, so listen, to answer this question, you would say that Paul would need 3.5 cups of broccoli to make 1 pizza. Now, next example. Shh, come back to me, please. An average rate of speed is the ratio of distance traveled in an amount of time. Distance over time is rate of speed. The ratio is a rate because the units being compared are different. So when you are doing a rate, your units are different. Okay, so we did this one where we did the 288 miles in 6 hours is how fast the family travels. But we want to figure out how many miles they go in 1 hour. So we go 1 times 288. 288 divided by 6 equals what label? Yep, I can just look here. What should it be? Miles. So we could say that they're traveling at a rate of 48 miles per hour. Good. All right, it says the unit price is the price of 1 unit of an item. So you do like cost per 1 unit. Sometimes that unit will be pounds. Sometimes that unit will be ounces. It depends on what you're buying. Okay, it gives a chart of examples. If you're buying something that is liquid, it's going to be measured in fluid ounces, quarts, gallons, or liters. You can see this on soda pop, right? When you buy a pop, at the bottom of the label, it will tell you how much liquid is in the object. Wyatt, 4 on the floor, please. If you buy a solid, it will be measured in ounces, pounds, grams, kilograms. Okay. Look at example 3. It says the Lawsons stop at a roadside farmer's market. The market offers lemonade in 3 different sizes. What size of lemonade has the lowest price per fluid ounce? Okay, so we have to do 3 different things here. All right, look on to the side of the chart. We know that it will cost 89 cents for how many ounces? 12 ounces. I'm going to do column format because I need to convert, right, to 1 ounce, do a proportion. I know that it will cost $1.69 for 18 ounces, and I know it will cost $2.09 for 24 ounces. Right now, just looking at these, can you tell which one's the cheapest?
Yes.
Which one do you think it is?
It's a 12 ounce.
You think this one's the cheapest? Do you know for certain? Do you know for certain?
No. That's what I think.
Right, you don't know for sure.
Yeah, the bottom of the page does.
Right, don't look at the answer in the book. You don't know for sure. If I would have taken your book away, would you know? If I gave you 2 seconds to figure this out, would you have been able to figure it out? No. You would have had to kind of guess. So, to actually figure this out, you need to do a proportion so that every single second term is what? How many? 1. 1 ounce. Remember, this is creating what kind of rate? Unit rate for 1. Unit rate, 1. Okay, so I'm going to go 1 times 89 cents, which is 89 cents, divided by 12. I get 0.074. When we talk about money, we go to what place in the decimals? Hundredths place. So we have this. On the calculator, what do we round to? Stays the same. 7 cents. Okay, this kind of lemonade costs 7 cents per ounce. Let's do the next one. 1 times $1.69 divided by 18. We get this. What do we round? Stay the same. This one is 9 cents an ounce. The next one we go 1 times $2.09 divided by 24. We get this. Nope. Yes. The 7 tells the 8 to bump up. Okay. So if we go back to what we're asked to find, which one has the lowest price per fluid ounce? Right, so to answer this question, you have to do this. You would say the cheaper one, the cheaper lemonade is the 89 cents per 12 ounce. Okay, don't write this down necessarily because Do I know exactly which one that goes to? No. No. But you could say, if I said prove your work, could you say that 7 cents is less than 9 cents?
Yeah.
Yep. That would prove that you know that that's how you compared those numbers.